Notes are the first in our atmosphere unit. This is the last unit we'll do before the exam. We'll go through atmosphere in the next 2 weeks after Thanksgiving, and then we will do weather when we get back from Christmas break. So tonight we're going to look at what is the atmosphere, what gases make up our atmosphere on Earth, and also why is the atmosphere important, why does it matter for us here on Earth. So what is the atmosphere? Just to give us a basic definition, our atmosphere is the envelope of gases that surrounds our planet. Alright, and that's a pretty important definition. You probably want to get that word for word into your notes. And in these pictures you can see it, right? It's just this thin little sliver of gases. So most of the gases in the Earth's atmosphere are within about 100 to 120 kilometers of the Earth's surface. That's like 60 to 70 miles. Right, you can see pretty clearly in this picture that the atmosphere gets thinner and thinner as you go up, and we'll talk more about that next week with the Earth's layers. But it's this really thin layer of gases that surrounds the planet, and as you can probably guess, gravity is what holds it all in place. So let's talk about then what's in our atmosphere, or the composition. Alright, so composition, fancy scientific term, right, meaning what's in it. We saw that with stars, their chemical composition. So our atmosphere is made up of a mixture of different gases and particles. Most gases in the atmosphere are a constant percent, so they don't change from place to place. So one gas, nitrogen, that we'll look at in a second, no matter where you go in the world, nitrogen is always a certain percentage of the Earth's atmosphere. But one gas, in particular water vapor, can change. So we'll look at that separately because that can be a differing percentage depending on where you are. So let's look at the gases then that are in our atmosphere. So the gases in dry air. And so we look at dry air because water vapor can change. So as water vapor changes, these numbers can change. So we just kind of ignore water vapor when we talk about the gases that make up dry air, because that way we can look at them as a fixed percent. All right? So the gases in dry air, and I'll kind of add this in on our notes a little bit. So gases in dry air, which is no water vapor. You need to know the percentages for nitrogen, oxygen, and then everything else can kind of get grouped into other gases. So we've got nitrogen is 79% of the Earth's atmosphere. Oxygen is only 21%, right? Despite the fact that it's super important, oxygen is only 21% of our atmosphere. Nitrogen, which makes up, I'm sorry, that should be 78%. 78%. Nitrogen, our body does nothing with nitrogen. It comes in, it goes right back out. Your body doesn't use it at all. Oxygen is 21%, and then other gases are 1%. And this includes things like carbon dioxide, argon, and other gases. All right. And as we'll see in a second, then water vapor can be anywhere from 0 to 4%, depending on where you are. So, but when we look at just dry air, the biggest gas by far is nitrogen, looking at this graph, then oxygen, then all this other stuff. So every time you take a deep breath, this is what you're breathing in. Now water vapor is water in the form of a gas. When water gets hot enough, it turns into a gas form, right? It evaporates. And the amount of water vapor in the air varies from place to place and from time to time. So it ranges anywhere from 0 to 4%. Rarely is it actually 0. There's almost always a little bit of water vapor in the air. But sometimes there's a whole lot. And we feel this as humidity. So on a humid day in the summer, right, that means there's more water vapor in the air, right? So that number is bigger, right? On a winter day when there's not as much humidity, that number gets smaller. All right, and then we feel this humidity, or I'm sorry, rather this humidity is super important for Earth's weather, as we'll see after the break. We get clouds, and this water vapor eventually condenses to form clouds, rain, and snow. So we don't need to worry about that now, but what's important to know is that, right, air isn't really dry, and the water vapor amount can change. All right. And then our last little bit of composition is the particles that are in our air. Alright, so pure air with no particles in it exists only in labs where you have super strong filters, right? We don't have one of those at school. You do have a filter at your house in your air conditioner that takes out a lot of dust, but it still won't take out everything. So all air contains tiny solid and liquid particles. Pollen, dust, smoke, salt, other stuff. Most are too small to see. So when you breathe these in, some of them go right into your lungs, come right back out. Some of them get caught by your lungs, right? And that becomes mucus and other goop that you end up coughing up. And most of these things are too small to see. So, you know, like pollen, especially in the spring, you can sometimes even see it in the air, right? And you're breathing this in whenever you breathe. It's not necessarily a bad thing. And we'll see that you need some particles for weather to function. But obviously some stuff like smoke and other pollutants, if there's a lot of that, that can be harmful to human health. So the last thing we want to look at tonight is why does the atmosphere matter? Why do we care? So why is it important? And the atmosphere is important because it does a couple different things, right? First off, it traps energy from the sun. I should say from the sun, not from the sun. It traps energy from the sun to keep Earth's surface warm enough for water to exist as a liquid. Alright, so it's kind of a mouthful, so we got to try and rewrite that in our notes, make it a little bit shorter. Right, but without the atmosphere at night, Earth would get so cold that all the water would freeze. But that doesn't happen, right? It doesn't get super cold at night. The atmosphere acts kind of like a blanket to keep some of that energy here. It protects us from solar radiation. So in addition to giving off light, we'll see that the sun gives off other kinds of radiation that would be harmful to us, and the atmosphere blocks a lot of those. And it also protects us from getting hit by meteoroids. Right, we've learned about meteors already, and the atmosphere blocks us or protects us from those meteors. All right, so tonight, make sure you finish this up, write 3 questions at the bottom, and I will see you guys in class tomorrow.